Jai Hind everyone, myself is Nikhil Kumar, Department of IT in Ajay Kumar Garg Engineering College. Today I have a lecture on theory of automata and formal language. Basically, it is the code is the BCS 402 and it is also known as the automata. So in this lecture series of automata, we will discuss in this proper lectures meaning of automata, requirements of study TOEFL, finite state systems, DFA with examples and also NFA with examples. This topic is considered in the AK2 syllabus in the unit 1. Basically, it is for the second year CSC and CSC allied branch. So, what is the automata theory? It is also known as the theory of computation. I already discussed that it is a theoretical branch of computer science and mathematics which mainly deals with the logic of computation. Basically, what will happen in the back side of the computers, the computations is performed many times. So, the logic is generated from the back end and it is the concept of the automata theory. The automata is originated from the word automaton, which is closely related to the automations. The concept of the computer is directly related to the automata theory. So, when we use the any logics in the computer system, basically it is directly connect with the automata. So, my first topic is regarding this, the finite state system. What is finite term? A finite state system is a model of computations. Basically, the finite term is specified in the term of numbers, so that we can specify the numbers, we can measure out the numbers. So, it is the finite term. The finite state system is basically when we considered in the discussed in the terms of state from initial to final state, the number of states we can be measures. So, it is the finite state. And in the case of the automata, that is a TOEFL, the finite states FA, finite automata, or we can say finite state or finite automata. Finite automata is broadly classified into types. First one is the DFA and second one is the NFA. When all the input is processed, we observe the system's final state to determine whether the input sequence was accepted or not. Basically, after the initial condition is something and after apply the input on that particular initial states, the moderated states generated, and after moderated state, it may be the final state or nothing, or basically the intermediate. But after the apply the inputs to the all intermediate states, the final states occurred. So, we can represent this term in such a way. Let's suppose it is a term, it is a initial state, then secondary state, that is the intermediate state. We can say Q1, then Q2 and then Q3. Here in this basic diagram, it is the initial state and Q1 and Q2 is the initial state, that is the intermediate states or is the moderated states, and Q3 is the final state after the initial processed multiple time. So, in the whole concept of the finite automata, there are 4 states: initial, Q1, Q2 and Q3 that are measurable. So, it is called the finite states. So, next term is the DFA. It is known as the deterministic finite automata. When we can justify that at a particular state, after processed the input at that state, the term that generated from that states is executable form. That means we can find out that if we apply the input at a particular state, let's suppose Q1, and we apply the input let's suppose 0, the state generated from that mechanism is Q1. Let's suppose it is Q1. If we can find out that it is the Q1, not the other one states, so it is the deterministic finite automata. The basic funda for the DFA is that when we apply the input symbol on a particular states, we find the correct a singular unique states. If it is the number of state find out for given the single input, then it is other than the DFA. We will discuss later. So in the deterministic finite automata, in short form DFA, basically we are ensured and we are sure properly that after apply the inputs to a proper states, we find the exact number of next states. So what it say? DFA refers to the deterministic finite automata, and deterministic refers to the uniqueness of the computations that I already discussed. The finite automata are called the deterministic finite automata if the machine is read an input string one symbol at a time. It is the same what I discussed. In DFA, there is only one path for a specific input from the current state to the next state. Means that when we apply the input to the particular state, we go through a particular state, not more than once. In the case of the DFA, DFA can contain multiple final state. It also may be that after apply the inputs to the intermediate state or the initial state, we can move to the multiple final state. It is the basic funda of the DFA. So the formal definitions of DFA contains a collection of 5 tuples. As discussed here, it is the 5 tuples we used every time to describe the finite automata DFA, as it is with the term capital Q, that is the finite set of states. Actually, that is the non-empty finite state of states. That means at least one state should be exist in the DFA. It is represented as capital Q, and sigma is the finite set of the input symbol. It should also be the non-empty set of input symbols. That means at least one input symbol should be exist in the DFA. Q naught is the initial state. We can represent every time Q naught for the initial state, and capital F is the final state. It may be more than once, and delta is the transition function. That means if we apply the input to the particular state, after moderation the output to the next intermediate state will be generated, and it is represented as the transition functions. So we can say that transition function can be represented as Q into sigma drive to the set of Q. That means that capital Q represents the set of state, so that when we apply any particular state, the inputs after process, we find the next state, it will be a part of the subset of the capital Q set. So it is the graphical representation, how we represent the DFA in the graphical forms. Here it is a very basic DFA model. Here Q naught is the initial state, Q1 and Q2 is the other states other than the initial state. So when we represent the Q naught, that means when we represent the initial state, it is represented as Q naught, circle around it with the directed directions. It is the initial state. And for the state of the final state, we use the multi circles, and let's suppose it is the state Qn. So these are the terms for this particular DFA. We represent in such things here. Q naught is the initial state. Sigma is the input symbols as I discussed earlier. Here in this case 0 and 1 is the terms are used in this DFA as the input symbols that are non-empty, and capital Q is the set of all the states including final and initial state. So here is Q naught, Q1 and Q2 are the set of states, non-empty sets, and F is the set of final state. Here in this particular questions, Q2 is a single state, that is the final state. Okay. Yeah, everything is complete. One more thing should be noticed every time, that when we design the DFA or NFA also, every time at each of the state when we apply the inputs, we all apply all the inputs. Likewise, that in the case of the Q naught, we apply 0 and 1. Here in the Q1 we apply 1 and 0. Here in the state Q2 we also apply 0 and 1. That means at each state we apply all the input symbols that are used in that DFA. And if in the case we did not get the state of the final state, in that case that state is known as the, if we not move in line the final state, that particular state is known as the dead state. Let's suppose if there is a case that Q naught is the initial conditions and Q1 is the intermediate state and Q2 is the final state, after apply the some input 0 and 1, let's suppose 0 and 1, but here 1 and Q3. So Q naught, Q1 and Q2 is inlined in such a way, from the Q naught we goes to the Q2, but here Q3 is just far from that particular DFA model. So we cannot move from the Q3 to the Q2. We cannot move the Q3 to Q2 in any case, because it is a unidirectional nature from initial to the targeted final state mode. So this Q3 is known as the dead state. How can we represent this particular DFA model to the transition table? Here we represent the present state. Here the first input symbol, after apply the first input symbol, what will be the next state? Here it is represented. It is here we represent the next state after apply the input 1. So for the case of the Q naught, after apply the 0, it is self loop. So it is represented here Q naught. For apply Q naught, when we introduce 1, apply to the state Q naught, so it goes to the Q1 represented here. In the case of Q1, when we apply 0, it goes to Q2, and we apply the 1, it is self looped. For in case of the Q2, it is 0 and 1 self looped. So it is basically the transition table for the DFA model. We generate the transition table for NFA in the same manner as discussed as for the DFA case, but some changes are applied in that NFA. So there is one more question for the DFA case. A DFA with input symbols 0 and 1 accepts all strings with 0. That means if we apply all the strings that are connected, that are in line with string 0, so it should be the generate the output state. Okay, what will be the string? Let's suppose starting with 0. all starting with 0. That means it may be 0, 0, 1, 0, 0, 0, 0, 1, 0, 1, 0. It may be the string that passed from that DFA model. So we try to generate the DFA model. So here Q naught is the initial state. When we apply the first input symbol, input symbols are 0 and 1. When we apply the first input symbol 0, it should be the resultant value, because the basic criteria is it accept all starting with 0. So initial conditions is this one. So here Q1 is the output state. So it goes to the output. But when we apply in the string 1, 0, 1, 0, 1, 0, it should not be goes to the final state. We also try this one. When we apply the 1 here, apply to the input state Q naught, it goes to the Q2, that is not the final state, and it is the dead state. So this is the basic, this is the particular DFA model for this language that accept all the strings that starting with 0. Let's suppose we will try some more things, some more strings to be applied. Let's suppose 0, 1, 0 is accepted or not. We will check that. First, after apply 0 at the strings, the state will be Q2, Q1. Then 1 apply self loop, then 0 apply self loop, so that this Q1 is the final states for all the inputs that start with 0. Okay, we try that 1, 1 accepted or not. In this case, when we firstly apply 1, then it comes here. Then when we apply 0 and 1, it will be self looped here and never goes to the final state. So that we are very ensure, here in this case, we are very ensure that the all the strings that carry with the starting 0 will go to the final state, and the other state other than this criteria will never be go to the final state, that is the dead states. The next one is the next question is the DFA with input symbol 0 and 1 accepts all ending with 0. This is the other one question. All ending with 0. What will be the strings? 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 0. These strings should be passed and these strings should not be passed. 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 0. So this is the basic model, and this is the DFA model for the language. DFA with the input symbol 0, 1 accept all ending with 0. So we try for the case of input symbol 0 for the string that we will check out that these strings is passed in this particular DFA or not. When we apply 0, 0 is passed for the, and this is the final state. Q1 is executed, and for the case of 1, 0, 1 is self loop, 0 here it is also passed. For in case of 0, 0, 0 and 0 it is passed. For 0, 0, 0 self loop. So all the string that ends with 0 is passed here and goes to the final state. But in the case of the string that contains the 1 in the last bit, we will try that. When we apply the ones, when we apply the multiples ones and the initial conditions, so it will be self loop and never goes to there. So all the strings that carry the 0 at last will go to that particular final state, and the string that does not contains the 0 at last will always switch the self loop and the starting state. Let's suppose 1 0 1 1 0 1 0. It is some different thing. We will check that it is accepted or not. 1 self loop, 0, then 1 and 0. So it is a perfect minimized model for the DFA case for the particular given language. So it is also be noticeable that when we design the DFA model for a particular language, we use the minimum number of states. It may be that after apply the max some more than we include some more states, then it will be a DFA model, but it will not be the perfect one. So for the perfection of DFA, we use the minimum number of states and apply all the input symbol to represent the particular final state, dead state, initial and intermediate states. So next question is the design the DFA with input symbol 0 1, accept the set of all strings with 3 consecutive zeros. With 3 consecutive 0 means it should be 0 0 0 for the accepted case, 1 0 0 0, 0 0 0 1, 1 0 0 0 1. It should be accepted, 1 0 1 0 0 0 1. And for the rejection, 1 1 0 0 1 0. We will try this one. For what will be the basic? When we only have the 3 consecutive 0 and other than no any bits are here. So 0 0 0. It is the final state. It is the initial state. These are some intermediate states. So we go to the final state. Then when we have the term string 1 0 0, what is happened? 1 consecutive 3 0. Then also the final, we goes to the final state. When we use this one, 1 0 0 1. That means when we have the multiple time 1 in the starting mode and have the consecutive zeros, 3 consecutive zeros, and then multiple times 1, then we also have the final state. Let's suppose a criteria that we have 1 0 1 0 0 1 1 0. Here 1 is not mentioned, so we can use that this one. If 1 comes here, we will switch to the initial state. Here in this case, in the particular position of the Q2, here if 0 is applicable to the input state, so it moves to the Q3. But if 1 is applicable at this state, we switch to the Q0 to the initial conditions. So we use the 1 here. So it is the perfect one, DFA model for this particular language that contains the 3 consecutive zeros. Next one is the design a finite automata with the input symbol 0 and 1, accept the strings with an even number of zeros followed by single 1. That means if we have even number of zeros, what can be that? Let's suppose 1 even number of zeros, 0 0 1, 4 times 0 1. If such type of strings are given, it should be accepted. So we will try. If there is not any zeros, then it should be the final state after apply the ones. When 2 zeros, 0 0 and 1. When we have the 4 times 0, that is the even. Here 2 zeros, here 4 zeros, 6, 8. Such type of zeros. 1 2 0. When we have 4 times 0, 1 2 3 4, then 1, so that it is the final state. It is the intermediate state. So what is the next term is the NFA, that is the non-deterministic finite automata. It is also known as the DFA, but in basically we use the term NFA to represent the NDFA. Understand? non-deterministic finite automata. It contains the same features as DFA, but the basic difference for NFA and DFA is that in the case of the DFA, when we have the input, when we have the any state, let's suppose Q naught is the state, initial state, basically state or initial state, and we apply any input symbol. Let's suppose A is applied to the state Q naught. We goes to a unique state, that is a Q1. But in case of the, it is the case of the DFA. But in case of the NFA, what happens when we apply the input symbol A to the particular state Q naught? The multiple state will be generated. So it is the basic and fundamental difference between DFA and NFA. Finiteness are in both the terms NFA and DFA is applicable, because these are the two broad terms for the finite automata. And one more thing that is noticeable here, that in NFA contains the null value also. That means without apply the input symbol, any input symbols, we can move to the next state. It is in the concept of the NFA. So the transition function is here, that Q into E trans to Q, because it contains the multiple state will be generated after apply the inputs. It also contains some tuples, have the same meaning as discussed for the DFA case. It is the basic one NFA model, NFA or NDFA model, where Q naught is the initial conditions, Q1 is the output state. When we apply the input symbol to that particular state Q naught, when apply the input symbol A, then it also goes to Q1 and Q2 also. But in case of the DFA, it will be moved to Q1 or Q2 in a particular state. So what will be the graphical representations of NFA? It will be the same as DFA. We use the initial, for the initial state we use this term Q naught. For the output we use the, let's suppose it is the N term, double circle. And for the transition we use the directions arrow. For the state of the dead state, we use the term this one. Let's suppose Q4 is the dead state, that it can be represented in such a way. The transition table will differentiate the term DFA and NFA in such a manner. We always have the single term here for the case of the DFA, but in case of the NFA, we can find out more than one term for the input 0 or 1, likely this one. In case of the DFA, we always use the single terms. And it is also discussed earlier, like in the case of the NFA, we will use the terms epsilons. That means without any input symbols. Thank you very much.